Hello, we are the Voice Recognition Group, and this is our aptly named Voice Authentication software. Our project is a desktop application that acts as a password bank to automatically log you in to your favorite websites. To get started, a user first needs to register with our system. Now, during this registration process, the user reads sample text in order to train our system. For the sake of brevity, we'll use an account that I've pre-trained. Once registered, we can log in. We are given a randomly chosen sentence designed to compare the user's acoustic model with a variety of phonemes from the speaker. Once upon a time, there was a man who liked cheese and happily ate it on a cracker. Now, to authenticate a user's voice, we have implemented a SOAP-based web service to run MATLAB on a server. Now we can see that I can log on successfully, but what happens when someone else tries to log in with my username? If I call my good buddy Mike over, let's see what happens.
Given the choice, would you choose money or happiness for the rest of your life?
MATLAB is called on the server again, and we'll see that Mike's voice sample does not meet the threshold to match my acoustic model. For times when the user is sick or has lost their voice, we allow the user to sign in manually with their password. Upon a successful login, we are able to add or edit a user's website credentials. From there, all we have to do is hit the website login button, say the website name, and we'll open a browser with the user logged into the website. Reddit. Our speech recognizer consists of a custom dictionary of websites we built on top of the Sphinx 4 speech recognition library. As you can see, we're currently logging into Reddit. To understand how the voice authentication works, we'll have our group leader Jason Dove use some big fancy mathematical terms to describe the MATLAB code.
The speaker recognition in MATLAB is performed in 3 steps. The MATLAB code will receive 2 wave files from the user, one corresponding to the original training file, usually 30 to 60 seconds of speech, and a sample of their voice that they will provide each time they log in. The sample can be as short as 3 seconds. The first step in the algorithm is to compute the Mel-Kepstrel coefficient matrices for each of the wave files. Each row in the Kepstrel coefficient matrix corresponds to the value of the coefficients at a small time window in the wave file. For any given row, the coefficients are computed through a series of Fourier transforms. Once the coefficient matrices are computed, the matrix generated from the training data undergoes a second process. In order to compare the 2 sets of Kepstrel coefficients together, a Gaussian mixture model is constructed for the training matrix. Given this Gaussian mixture model, it is possible to, for any given row in the sample matrix, calculate a probability that the row belonged to the same speaker as the training data. After calculating this probability for each row in the sample matrix, the probabilities are combined to get a total probability that the sample and the training data are from the same speaker.